Yes, sir.
So last time in the saddle support, we know the expression for the bending moment. Now how to calculate the bending stresses. So bending stresses in the cell at the saddle due to M1, bending moment 1. So if the stiffness is enough to maintain a circular to maintain a circular cross section that is within this distance 0.5 r. The whole cross section is effective and therefore the stress due to bending is at the topmost fiber of cross section K1 pi r square t and at the bottommost fiber of cross section F2 equal to M2 K2 pi r square into T. K1 equal to if A is less than equal to 0.5 of R, we can consider A1 equal to K2 equal to 1 and for A greater than 0.5 R, okay, the cell is not sufficient, the cell is not sufficiently stiffened by the paint. So in that case, the value of K1 and K2 fixed for 120 degree, 107 and 0.192, for 50 degree, 0.161, 0.279. And what is the stress for M2? This is a stress for M1, and stress in the cell at the mid span due to M2 is M2 by pi r square T, is maybe tensile or compressive, both, okay, whatever, depending on the position of the fiber. Okay, for the topmost it is tensile, for the bottommost it is compressive. Now this T thickness, this T, or before what we have used in this stress formula, okay, T is without corrosion allowances. Now a problem, you will try a problem. Suppose the vessel diameter, you will try, okay, vessel diameter. Don't ask me, sir, what is inside diameter, outside diameter. Okay, vessel diameter is 1230 millimeter. Length of cell, length of cell equal to 8000 mm. Okay, torus spherical head, torus spherical head whose crown radius RC, crown radius is 1250 millimeter. Knuckle radius is given as 6% of diameter. You will calculate 6% of diameter. Total depth of head, total depth of head, 257 mm, 257 mm. The angle saddle makes with the center is 120 degree. Working pressure, This is working pressure, so you have to multiply by a factor of safety. Okay, for design pressure. Working pressure is here 0.5 Newton per mm square. Cell thickness 10 mm. Head thickness 12 mm. Next, corrosion allowances 1.5 mm. Permissible or allowable stress 95 Newton per millimeter square. Weight of the vessel and content. Weight of vessel and its content. It is 119430 Newton. A. A value is given, that is the distance of saddle center line from cell end. A equal to 320 millimeter. Okay, now find this M1, M2, F1, F2 and F3. ठीक है, ठीक है. So do it. It's assigned to you. You do it very easy. Only formula based. Now, the next thing we will switch to the flange. So, what is the purpose of using flange? Suppose we want a detachable head. Cell is there and we want detachable head, so that we can remove the head from the cell frequently for cleaning purpose or other purpose. So in that case, we use flange to join the cell with the heads. Now for joining two parts, the two pipes, okay, we use flange. So a flange joint, a flange joint consists of consists a pair of flanges one each attached to the two component of the piping system to be joined, and it holds securely together by a series of bolt, or stud. And to make it completely leakage proof, so that no leakage from in between from the rough surfaces of the flanges, a gasket is used. I will show the diagram. A gasket, is interposed between the two adjoining flanges faces. Okay, so just to wait some time. Okay, now the classification of the flange. Classification of flange. So flange may be classified by different ways. First is the standard flange, which is easily available. The specification is fixed. So that is the standard flange. Standard flange. Similarly, there is non-standard flange also. Non-standard flange. Okay. Next is that white face flange. And last is that narrow face. Narrow face flange. Now, what is this? Standard, non-standard, white, and narrow. So, standard flange. Standard flange that is designed by Indian standard. Keep writing. Designed by Indian standard organization. Most common in pipe joint connections between small diameter cell and head. Most common in pipe joints connection between small and between small and between small diameter cell and heads, and the working condition is moderate pressure and temperature. Use standard moderate, low to moderate, pressure and temperature conditions. Now the non-standard flange. It is designed according to your needs, specification, specific material, shape, size, bolting arrangement. Okay, for special cases, it is designed. So design as per requirement with specific material. Suppose you want to make it by brass or copper, so that is stainless steel. So your requirement with specific material, shape and size, bolting arrangement, etc., etc. It is formed from structural section, or plate. And specific designs procedure need to be followed. Next is that white face flange. White face flange. Here the gasket extend over full width of the flange. It is suitable for low pressure, suitable for low pressure and temperature operation. Less than 200 degrees Celsius and 20 kg per centimeter square pressure. Bolt load is high. The load experienced by the bolt. Bolt load is high since gasket is applied all over the flange face. Another characteristic is larger number of or large number of bolts are needed and costly manufacturing. Okay. And another is that narrow face. Narrow face flange. Here the characteristics is portion of the flange face is raised and finished with spiral or concentric grooves. Spiral and concentric grooves to hold a gasket. To hold the gasket. And the gasket with flat ring type is less than the width of the rest face. Width of rest face. Okay, it has different types, as for example, rest face flange, rest face flange, male and female face flange, male and female face flange, tongue and group face flange. We will show all these. Tongue and groove face flange, and another is that ring face flange. Ring face. This is the types of the narrow face flange. Anyway, now we will discuss all this one by one. And flanges may be another type depending on their attached or attachment. Okay, so this is based on their face, narrow face, wide face, or standard, non-standard. And another type flange may be of how they are attached. So I am showing that at first. So you can see this PPT. You see here, so here we will show that different type of flange by or the way it is used to join the pipes. Okay, so this may be the weld neck, slip on, socket weld, lap joint, threaded and blind flange. Now again I am repeating, so here it is. What are the flanges? Flanges are the second most, okay, after the welding, the second most used method for joining two parts of a pipe or two parts of an instrument. Now, flange connect the different parts of the pipes by means of bolting system. Different types of ends are used to connect flange with the pipe depending upon the design requirement. Now we will show the different type of flange, the way it is attached with the pipes. Now you see here the first picture. This is the flange, and it is, you see here, here is a thread. You see here the thread is here. Anyway, so this is the flange. Two four bolt hole are there, and the pipe will attached with the flange by means of this threaded or thread joint. And the schematic diagram is showing here. So this is the flange and the pipe is attached. Okay, the outside to diameter, okay, outside surface of the pipe is also threaded and is attached by the threading. Okay, so one is the threaded flange total. Two is the, you see here the red color, this is the thread. Three is the pipe, okay, or the fittings. So this type of flange is known as the threaded flange, and this category is the way it is attached with the pipe or equipment. Okay, and threaded flange also known as the screwed flange, and it has thread inside the flange bore which fits on the pipe, matching male thread on the pipe outside. And you see here this type of joint can easily be dismantled or attached. But one limitation is that it is not suitable for high pressure and temperature applications because of the threading there may be a chance of leakage. So high pressure and temperature operation not allowed. Where it is used? It is used in the utility services as per the water pipe connection, air pipe connections like this, normal condition. Now, second is the socket weld flange. You see the flange. Now, there is no threading, okay, but a socket type arrangement is there so that the pipe can go through this, okay, at up to a certain distance, okay, and it is welded. You see here it is welded. So this type of flange is known as the socket welded flange or socket flange. Now you see here a socket oiled flange has a female socket, okay, on which the pipe will go through, okay, in which the pipe is fitted. And there are different type of welding, okay. So fillet welding is one type. So fillet welding is done from outside of the pipe, and generally it is used in small bore pipe, okay, small boring pipe, and suitable for low pressure and temperature application. Here also for low pressure, temperature, and for low bore pipe. So this is the socket weld dead flange. You see here, and a certain gap 1-2 millimeter is maintained here for the in case of there is a severe expansion. So a gap is maintained in between these two faces, the pipe and this flange face. Another is same. The number 3 is the slip-on flange. Okay, you can see here this is the flange, and the pipe can go through this diameter, okay, of the hole. So it can slip. So that is this type of flanges is known as the slip-on flanges. And let's see, okay, the small holes with matching outside diameter of pipe, which pipe can pass through this hole. Okay, so there is no barrier, so the pipe can go through this or pass through this hole, and so it can slip. So that is known as the slip-on flange. But here, okay, socket and weld, the pipe cannot fully pass. Okay, so that is known as the socket welded. This is a socket. So come to the slip-on flange. The flange is placed on the pipe and fillet welding is done. You see here welding throughout the outside diameter of the pipe with the flange is done. And it is suitable for also low pressure. It is suitable for the low pressure and temperature application. This type of flange is available in large size also to connect large size bore pipe with storage tank nozzle. Okay, with the nozzle, this can be fitted. Next is the lap joint flange. You see, this is the lap joint. Okay, this portion is marked here as yellow, and with this portions the pipe is fitted by the welding, and this type of is known as the lap joint flange, and it has two components. You see here a stab end and a loose backlink flange. Okay, number 2, you see here stab this is the stab end, and other is the backlink flange. Stab end is butt welded to the pipe, and backlink flange freely move over the pipe. Okay, so the stud is welded with the pipe. Here is the red spot. It is welded, and the flange can pass over the pipe. Now here is another, and in the left side there will be another similar type of flange and attached by bolting. Now lap joint flange is used where frequent dismantling is required. and a space is constrained. So where the space in the axial direction is small or not too much available space is there, so for that type of cases joining the lap flange may be used. Next is the weld neck flange. I will present this PPT. Okay, weld neck flange. You see here, it is a taper portion is attached with the board. Okay, the and a pipe is attached with this neck. Now, weld neck flange are mostly widely used flanges in the process piping. It gives the highest level of joint integrity due to the butt welding with a pipe. Okay, it is the pipe butt welding. This type of flanges are used in high pressure and temperature. Weld neck flange are bulky, costly compared to the other flange. And at last, this is the blind flange. There is no central hole. So to stop a flow at the end of the pipe, or to stop or to close the nozzle of a tank or pressure vessel, this type of flange is used. Okay, no central hole. It can be connected with the other parts by the bolt or stud. So this is the blind flange, is a blank disc with bolt holes. This type of flange are used with other type of flange to isolate the piping system or to terminate the piping as an end. It can be used as a manhole cover also. So this is the blind flange. You see here? Okay. And this is the gasket. Gasket is placed in between the faces of the flange pair always. It is shown here only, but in the other cases also the gasket is placed, interposed. So this is the red color is the gasket. Okay, in other cases also the gasket is there. So these are the type of the flanges based on the way they are attached with the pipe. Threaded, socket, slip, lap, weld, blind. And the other is that other type or other classification of the flanges is the it depends on their face, wide face and narrow face. So we will continue the discussion, wide and narrow. Okay. And you can consult any book for further details. Okay. So we will continue tomorrow. Fine. And do the problem. Okay. Thank you.